An international disease monitoring system initially developed for soybean rust is now being expanded to include other common field crop pathogens. Industry, university, and government are working together to make this system a useful tool for producers across North America. The surveillance system uses passive and active spore collectors that sample the air and rainwater. These samplers are stationed in 9 fields, or sentinel plots, over 5 provinces, including the University of Guelph's Bridgetown campus. Omafra crop disease specialist Albert Tenuta hopes to further develop this aeronet across Canada.
And so we've been able to set up a network where we use sentinel plots, spore trapping, disease forecasting models, and prediction models to assess the risk for producers in terms of what their risk would be for soybean rust and other diseases now. So we've taken what started off as a one pathogen type system on soybean rust, but now we've been able to expand that now to include the wheat rust, as I said, with stripe rust, leaf rust, and stem rust as well.
Airborne pathogens are caught in the sampler's filters, which are sent to the lab to determine which bacterial and fungal species are present. This could act as an early warning system for producers by identifying diseases before they're visible in the field.
And in many cases, the important part here is to develop the risk, but also provide more time for management options by producers. So if we need a fungicide application, an extra week to 2 weeks makes a big difference in terms of managing those diseases. The old days, if we saw a disease, then we'd have to go in and manage or spray it. And at that point, we're off on some yield loss. This way we can be much more proactive, and that's one of the key things.
Tenuta says this system can be combined with scouting records and climate models to develop accurate disease forecasts that can predict the levels of certain pathogens in each area. This would allow producers to consult the disease risk map for their location and help researchers compare disease prevalence from year to year. An increase in spores collected over time could mean a pathogen is becoming more potent and the current resistant varieties may no longer be effective against it. Researchers can use the filters as a source of DNA to design crop varieties that have greater resistance to the new, more aggressive forms of disease.
That filter collects all the spores that are out there, and that's where DNA fingerprinting begins, in the field. Mining this DNA that's on these things now for all fungal species, all bacterial species as well. If there is any sequence out there for DNA, we can find it.
Tenuta says the success of the soybean rust surveillance system was achieved through the cooperation of many partners within agriculture.
And I think it's the best example how if everybody works together, we can provide the best information out to the producers, determine the risks or lack of risks, and then go out and manage them.
With the help of international collaborators, Tenuta hopes to increase sentinel plots across North America so more producers can benefit from this disease monitoring system. From the University of Guelph, I'm Natalie Osborne reporting for Spark Air.